We are live. Hey, you guys. I found something freaking crazy. It turns out all the stuff that I was talking about on stream yesterday, I was right. And, Atari's broken. Because of a stupid wrapper that was proposed in order to address a hypothetical issue that was never shown to actually happen in practice. Yeah. So, this is just going to be a short little stream because it's late. I've been working on other things all day. But I'm going to look at these experiments. I'm going to finish writing this article on stream. I'm going to post this article in the morning tomorrow, and I'll stream all day tomorrow. But today we're just going to finish the article. Going to hang out here for like an hour maybe. And we're going to look at some experiments. We're going to relaunch some new experiments. And we're going to take it from there. Like, I don't know how this happens that I keep finding errors in, like, huge papers that have just gone unnoticed for years. Like, they're not... Okay, they're kind of subtle, to be fair. It's broken? Yeah, it's broken. Look, this is Pong. Here. You know what? We'll show you Pong before and after. Is this it? Yeah. Wait. Hold on. Let me make sure I have the right graphs. Nope, these aren't the right ones. We have even better ones. I think this one. Okay. Here's Pong. Fixed, right? This is what it's supposed to be. Really easy environment. You solve it. And here is Pong with the terrible bad wrapper thing. Broken. +600 citation paper. So, I'm going to just finish out writing this article on stream, because I may as well. I'll go through it a little bit on stream, because may as well. So the problem is sticky actions. They're real bad. Sticky actions mean that when your agent takes an action, it holds the key down sometimes. So it makes you repeat actions. And this was proposed as a method to break determinism. So you couldn't just memorize the optimal thing to do. And the author said that this doesn't break DQN. This doesn't break like actual learning algorithms. But actually you can prove based on the data in the original paper that it does. And it replicates on PPO, it replicates on my latest, all the new infrastructure. And it totally breaks like one of the easiest environments out there. With this modification, it makes it, I don't know if it's impossible, but it makes it a heck of a lot harder. And if it is possible, it's not happening with this giant hyperparameter sweep I'm running, so. Welcome, YouTube folks. I'm just going to finish this article up on stream tonight. I figured I could stream writing this and like chat and hanging out, or I could not stream it, so figured I'd stream it. Let me see. Let me finish. I think I had... Yeah, I was working on just fixing up this figure. Hold on. Qbert. So I need the original Atari environment out of this, which is like here. Sequest. Is there any other ones? 1, 2, 3, 4, 5. Wait, 6. Yeah, just Space Invaders. Let's grab Space Invaders, and then I'll tell you why this chart is so important. I guess I should have expected a few people to hop in the stream when I make a title like this, huh? Wow. Welcome, folks. RL is in fact broken. I have in fact fixed it. Specifically, Atari, which is the most widely used benchmark out there, right? It is broken. It's broken by a dumb wrapper that's become the standard. It's very sad. Let me finish this chart up. I think if I just cut it here. Yeah, there we go. Was there a caption that I'm missing? No, that's it. So, save, DQN, Auto, download, save. So as soon as I crop this figure and put it in the article, I'll explain what the data means. This will be in the article tomorrow, but you'll get an early preview of it. Edit. And then I just do, wait. Yeah, save. Okay. DQN Mikado. Where'd my table go? What? Come on. Okay, there we go. So, the data. Here is the wrapper that they say does not hurt performance. And this is their result. They say, look, we run it deterministic, which is normal. We run it stochastic, which is with our wrapper. And this is a dumb baseline that we expect to be broken by stochasticity. It's broken. DQN, the results don't go down. But the thing is, you can go look at the original DQN results, which has not just these 3 environments, but has 7 original environments. And then you can go down to the Mikado paper, which has full Atari experiment results with their wrapper. And you can see that in their paper, they do not do well on Pong or Breakout, which are 2 of the best known and most consistent environments out there. They substantially underperform DQN. So, in fact, if you look at all 7 environments, not just the 3 that they happen to pick, you can see that clearly this wrapper does, in fact, degrade the performance of DQN. And then what I'm going to continue writing here, the experiments that I did, this replicates on PPO, this replicates on like the latest RL infrastructure. If you try to run Pong and you run a big hyperparameter sweep, right, to make sure absolutely certain of everything, which is more than they did. If you do that, then Pong is like a trivial environment without sticky actions. And thus far, I've run like 100-something experiments, and it hasn't been able to do above 15-ish with the sticky actions, which is actually the score that they report as well. So there you go. This broke reinforcement learning. How does 30 to 40,000 step per second Atari training on 1 GPU without a dumb wrapper that makes the environments hard? How's that sound? That's what we've got in Puffer now. Gonna be real nice. Okay, comparing this to the original DQN results. Substantially underperform on Pong and breakout. Anything else they underperform on? Enduro is 470. Oh, they do fine on Enduro. Qbert. Ooh, they don't do well on Qbert, do they? No, wait, they're good on Qbert. Yeah, so it's mixed. That's fine. Are two of the best known, most consistent Atari environments. Let's see. As further evidence, I ran a large hyperparameter sweep on Pong using PufferLib's PPO plus LSTM implementation, which is with and without sticky actions. The environment is solved almost immediately without sticky, but only gets a maximum of around, I think it's 16 score. Yeah, 16 score. 16 score with them, which closely matches Chado's reported performance. Let's go copy some graphs. This. Do we put the filter? Let's see if it looks better with the filter or without it. This looks nice. We'll do like this. Let's refresh the page so we get this nicely. This is going to be a very nice finding because this is going to make it so much easier to do. Like, I think Atari is actually going to be reasonably usable. I never thought I would say that, but with how fast I have it training now, and without this dumb sticky action thing polluting results, like, it's pretty possible. For folks unfamiliar, sticky actions are like, this is something that basically everybody who's worked in RL for any period of time knows about. Like, for this thing to be wrong is nuts. Frankly, I'd rather that I'm wrong about this somehow, though I don't see how that would be possible. Like, I'd rather that I somehow be wrong about this and sticky actions not be wrong, just because of the amount of work this will overturn. Let me just make absolutely sure that I have the parameter right. So I use this graph if I just click any of these and I look for the sticky action parameter, where is it? It's not in train, it's in env. Repeat action prob 0, so no sticky actions. That's right. Sticky actions don't make a difference. Oh, they make a huge difference. They make a huge difference. I'll show you the two figures side by side. It's like this article is literally titled Sticky Actions Considered Harmful. That's how bad it is. Now, it's not going to be for all environments, obviously, but the key is that for some environments, yeah. What did you find out? Okay, so here is... Can I make this larger? I think I can just do it like this, right? Okay, so here's Pong. Full sweep without sticky actions. Immediately solves the environment. 20 is max score. Here's a full sweep with sticky actions. Doesn't solve the environment. Score caps around 16. And if you go into the original Mikado paper, they omit Pong results and break out another M's from their reasoning as to why sticky actions don't hurt algorithmic performance. But if you look at their original paper, I have the excerpts in this article, you can actually see that they do not solve Pong. They get around the same score, 15-ish, with their implementation compared to the original DQN solving it at 20. And they also substantially underperform on breakout, which is a very consistent task compared to original DQN at 168. They get like half the score. So, crazy finding. Absolutely crazy finding. Let me get this out of the way so I can have it on the stream nice. Random question. How do you think Tesla FSD works? Oh man, that's a way longer topic. I think, is the talk public? Andre gave a really good talk about it when he was chief scientist. He gave a really good talk at MIT. I don't know if it was made public. You might be able to find it online. It's changed a lot since then, I'm sure. But there's a good on YouTube. Yeah. I mean, that's a beast of a topic. It's not just straight reinforcement learning. It's like imitation for the most part nowadays. I do think that FSD is the most impressive deployed like ML application in general. Okay, let me make sure I title this right. I don't know, sometimes Pong gives you 21 score. I'm pretty sure the max is 20, so I don't know what's up with that, but I think that's like a well-known oddity. Uh, Currently Nestle working on backend systems, thinking getting AI, not sure where to start. How much math is required? Depends where in AI you work. Either not very much or a ton. In the type of work I do, my playbook I always say is about 5% math, 15% experimental science, and 80% straight engineering. You should probably at least know some matrix calculus, which is just normal calculus when you replace the variables with a matrix and occasionally have to flip one. What exactly do sticky actions do in reinforcement learning? Okay, so if you've played games ever, it's something that's incredibly stupid and like is immediately obvious that would mess you up. It makes your buttons sticky. So like if you press the button and then you go to press another button, sometimes the first button will stick down for a little bit and won't let you press the other button for a second. So like obviously that's going to get you killed in a lot of games, right? It's actually kind of obvious when you think about it for Pong. Like, in order to solve Pong, you have to win 20 straight games, right? So, like, yeah, of course, over 20 games, like, having your buttons be sticky is going to mess you up on a few of them. That doesn't sound useful. Why is it even a feature for this model? It's like the typical scientist thing. Like, this is like such an academic thing. So, the justification for this was that since Atari is deterministic, you can construct a really stupid algorithm that just memorizes the optimal sequence of actions, right? But if you mess with the buttons every so often, then you're not going to be able to just memorize stuff because you're going to go off of like the exact sequence of actions that you memorized, right? And then they did some experiments that show that the sticky action thing doesn't seem to hurt. They didn't do comprehensive experiments, despite later the same authors writing a paper about how RL is all wrong because nobody does comprehensive experiments. And then this just like got 600 citations and got put into the default wrappers of everything and is now making all of like RL wrong. It's like such a like, like scientist who's never played games kind of a thing as well. Because if you think about that for 2 seconds, like this is how I figured out that this was wrong in the first place, right? Like I was getting slightly weird results on Pong, and then I noticed sticky actions were default, and I just went like, huh. Sticky action seems like it would make it really hard to play a game, right? FD. That's not Rami Ismail, like the well-known game dev, right? I assume. FDSP. What's FDSP? Isn't determinism bad? Um. Sticky actions might act as a regularizer. Yeah, but in this case, it provably breaks the environment. So. So it's a sucky. Yeah, but it's not just a sucky regularizer. It's a sucky regularizer that's baked into the environment as a default setting when you instantiate. So when you like .make the environment, by default, this thing is enabled. What's the TLDR in this story? Default wrapper in the most common benchmark in existence makes the environments unsolvable. Where's entropy in here? Entropy is 004. Okay. And with this one, oh. So I need to include these loss curves, right? Oh, this needs to go down here. A really low res screenshot. Welcome, everyone. That is a lot of people on YouTube. It seems when you make a really clickbait, though true, title, people show up. The TLDR for folks that just got here, I found a bug in the default I found that the default processor used for Atari that is proposed in a landmark paper and is said not to degrade performance during training significantly degrades performance during training for at least one environment, probably multiple, based on both my own extensive experiments and the data presented in the original paper when you cross-check it against, cross-check their appendix against the paper that they refer to. So yeah, this is a big deal. This article will be published tomorrow. I will talk about it a little bit on stream. It will be on my X, which, I'll post the link. Because it will be here. And if you are generally interested in my work, which is attempting to make reinforcement learning sane, easy, and usable, all the stuff that I'm working on, including the stuff I use for the experiments, is available in PufferLib. This is the main library that I develop. It's all free and open source. If you want to help me out a whole ton, give it a star. It really helps me out. That's the TLDR. I'm going to finish up working on this article here. So another thing, got a general question on PufferLib. Seems you leverage Python to speed up your M's. Why did you choose that over Numba, JAX, or going end-to-end on the GPU with something like PyCUDA? Because JAX is a domain-specific language, which heavily restricts the type of environments that you can make. I'm able to get millions of steps per second, single-threaded, with way, way, way simpler code for much more complex simulations. I have a miniature version of Dota that is about 1,300 lines of Python that essentially looks like normal Python code. It runs at 1 million steps per second single-threaded. I've got this massively multi-agent snake that's like 200 lines of Python, looks like normal Python, runs at over 10 million steps per second single-threaded, all without having to write your code in a weird, like, vector domain-specific language. That is why. I actually have an article on this as well. This is more of a bait article, honestly, but people liked it. Where's this? Here's this article. I am not a fan of JAX as a general replacement for environment infrastructure in RL. I think it is a major step in the wrong direction. JAX is incredibly useful for physics stuff and for like specific A-life work, not as a general replacement for environment code. Let me grab that figure. How do I get this to be? Just give me reasonable font sizes. Yeah, there we go. Where's entropy? So here's the entropy loss. You can see that this is stable. It's not crashing entropy. And let me make sure I grab the right chart as well. Gotcha, that's very clarifying. And for Numba is the idea, since the code is running in C, there's nothing to gain from Numba's JIT. Yes, my environments will run, like the MOBA runs in pure C with no calls back to Python. At least, you know, the init is slow, but who cares if the init is slow? I didn't bother optimizing it. But like the step function will run at native C speed. Yep, I did this right. Let me filter this by, let me filter this by performance of over 10. Another good way of showing the JAX thing is just like go read the environment simulation code in the dev branch for like some of my M's, and you'll see how easy it is compared to trying to like wrap your head around how to do everything in array ops. It's really easy. One E minus 4 to 5B minus 3. I mean minus 3, right? 6e minus 3. Where's the minimum value? What was the minimum entropy value I allowed? Default. I want to make sure that I allowed a pretty low entropy. I think I allowed pretty darn low entropy, right? Yeah, 1e minus 5, that's what I thought. Oh, wait. I did this backwards. Yeah, I gotta do the other one, right? Because... yes, I have to do the other one. Okay, that was close. Almost screwed that up. That would have been very, very embarrassing. And it's about the same. So we'll do environment return greater than equal to 15. Oof, gotta be careful. If you're gonna claim that everything's broken, you gotta make sure that you do your analysis bulletproof, right? .3 to 1.5. 1.0. 1.0 to 1.5. 1.4. Okay, that was close. So... I need to increase the size of this, right? At 125%. Okay. So, based on this analysis, right, the best runs in this one, which is the this is the good one. Yes. So we find entropy values of around 0.9 to 1.4 compared to 1.3 to 1.5. Honestly, I'm shocked that sticky actions they don't always hurt training. They don't always hurt training. In fact, it's kind of weird. It looks like they do better on some envs, but the thing is, the claim was that sticky actions do not hurt training. That claim is wrong, and they are incredibly harmful to some environments. And if you're going to use sticky actions, okay, here's a really simple thing, right? If you're going to use sticky actions, you sweep it as a hyperparameter. You don't fix it across all the environments. And you especially don't fix it to a crazy high value like 0.25, which is the default. 1 in 4 button presses, the button sticks down. Isn't that crazy? I mean, I'm sure that, like, there are probably at least a few people in the audience here who do not play games. So, I mean, this is a crazy analogy, but, like, imagine you're trying to play a game, and then every couple seconds somebody comes by and slaps you in the face. That'd be pretty distracting, right? Well, okay, that's kind of what it's like when your buttons stick down and you can't, like, actually press the buttons you want. So, there's not a huge entropy difference here. Where's the sweep graph? Oops. Where's entropy? Entropy coefficient is 0.09 to 0.04. Perfect. Hate when I derank because someone keeps slapping me in the face, yeah? Well, I hate when my RL agent, when I spin my GPUs all night, and my RL agent doesn't work because somebody keeps holding my buttons down. It's a great way to push my buttons. So I have 18 graphs here. I think I could do this one a little better, right? Oh no, I did do this right. Like, I swear this is not just like... This is not normal in science. Like, just the amount of stuff that I find in RL here, like... And I wasn't necessarily looking for this when I was a PhD student, right? Because there's, like, not a ton of incentive to. But now that I'm just, like, actually, from a very practical and grounded perspective, just trying to make stuff work by whatever means necessary, I just find this stuff all the time. It's nuts. Why is this one so much smaller? Okay, there we go. I gotta say, though, the progress in reinforcement learning lately, just like the progress I've made in PufferLib in the last couple of months, RL is just such a different place already, and it's going to continue to get better and better. At this point, like, carb sweeps are pretty close to just solving whatever out of the box, and all we need really is fast environments. And like I have the snake env, I've got the particle M's, I've almost, I'm decently through on the MOBA. I've got a couple other M's I'm working on behind the scenes. Like, and once we get this, like the template out, like once we get the methodology down for just cranking out these fast environments, like we can do say like 7 Atari environments. I could probably crank those out in 2 weeks. So we'd have like an Atari 7, but it runs at a million FPS instead of like 40K. Million FPS on one core even we could do, as long as we're not rendering fully, like state based. Yeah, we can do a lot of stuff. We can do a lot of stuff really quickly. Maybe we can even do low fidelity rendering for all I know. Might not be that hard. I mean, they always downsample them like crazy anyways. Probably the observations we'll be giving them will be more reasonable than the squashed little frames that we use normally. I'm going to say one more time because the stream is doing particularly well tonight. If you want to support all this stuff, it's all open source. All the sweeps, all the tools and things I'm using, they're all in PufferLib. It's right here. Working on this full time. If you want to start the repo, it helps me out an absolute ton. The growth has been just nuts. I'm really, really happy with how this is done over the last couple of months. And I'm not going anywhere. It's going to keep going from here. Okay, let's do a little bit of analysis, since that's what people are here for, not puffer advertising. The axes are weird on this graph. Why did they do this? It's okay. I think it's okay. So, entropy of best runs, or greater than 15, without sticky actions, ranges from 0.9 to 1.4. Entropy coefficient for these runs is entropy is, that's 1e minus 3. No, it's 1e minus 2, right? 1e minus 2. 4e minus 3. P of best runs, score greater than 10, with sticky ranges from 1.3 to 1.5. Entropy coefficient for these runs is, and let's go grab the entropy coefficient for these. That's 6e minus 3. Wait, 1e minus 3 to 6e minus 3. One e minus 3 to 6e minus 3. Is that right? S 1e minus 3, 6e minus 3. Don't need this. Where's my draft? Okay, good. I'll put this note somewhere else. I don't really need to say this because I have 100 and 200 mil, and I checked it against both. Okay, let's go through this. And then we'll make like a fun graphic for this. And I'm going to order myself some food, and we'll end just like that. This will just be a short stream. Answer a couple questions if anybody has any, but this is like... Oh, yeah, I got to check the MOBA results as well. Because we have some sweeps that have run. I actually trained a cool policy that hopefully is good. Sticky actions considered harmful. Atari is the most widely used benchmark in RL. It is standard practice to randomly repeat agent key presses, making actions sticky. This technique was introduced by a landmark paper in 2017 with 600 plus citations, and it is the default setting in ALA Pi. The motivation was to prevent algorithms from hypothetically memorizing a fixed set of key presses to win the game, which is possible because Atari is deterministic. Sticky actions were broadly adopted because they cover this edge case and, according to the authors, they do not degrade the performance of DQN. Today, I use data in the original paper to show that this claim is false. I further demonstrate that sticky actions can massively degrade the performance of PPO, which is not learning deterministic policies to begin with. What's the DQN paper? Does this go here? Wait, I don't think that figure goes there. Original DQN result. Wait, this goes... Yeah, it just pasted this one here. This shouldn't go here. And then I have my little Joseph Suarez is a newly minted MIT PhD and full-time RL exorcist. I build... Yeah, this is fine. I'm just checking for grammar errors and reading through. Here's the table ablating stochastic, sticky versus deterministic actions. And it's cropped nicely. The impact of stochasticity on different algorithms. Asterisk beam writer free. Yep. Here are the original DQN results. Notice that Mikado et al. Only ablate 3 of the original environments. The 3 overlapping results roughly match. Original DQN does a bit better on Sequest, while Mikado et al. Do a bit better on Beam Rider and Space Invaders. Mikado et al. List full Atari results with sticky actions in the appendix. Comparing this to the original DQN results, we see that Mikado et al. Substantially underperform on Pong and Breakout. These are 2 of the best known and most consistent Atari environments. As further evidence, I ran a large hyperparameter sweep on Pong using PufferLib's PPO plus LSTM implementation with and without sticky actions. The environment is solved almost immediately without sticky actions, but only gets a maximum of around 16 score with them, which closely matches Mikado et al.'s reported performance. Make sure I got the right graphs. Carb sweep without sticky actions solves the env. Yep. Quickly solves the environment at 20 max score. Carbs hyperparameter sweep with sticky actions. Score gets stuck around 16, close to Mikado et al.'s reported result. But isn't determinism bad? Maybe, but PPO isn't learning a deterministic policy even without sticky actions. Entropy stays above 1.0 for all runs. Note that the entropy coefficient is included in the hyperparameter sweep, so low entropy zones are explored. All the best runs above 10 score range from, hold on, 6e minus 3 is the low end, 4e minus 3 to 1e minus 2. Is it 4e minus 3? Yeah. Is it really like that? Wait, 4e minus 3. That's 4e minus... Yeah, that's 1e minus 3. And then this one, 4e minus 3. Thanks for the stream, Night. Good night. Thanks for dropping by. This will be published in the morning. Obviously, I'm not going to publish it at this hour because algorithm. E minus 3. Look forward to reading it. Good luck. Thank you. And this is a pretty quick write. I'm not doing super long. I'm not spending tons of time writing stuff these days. It's like if I see something, I write a quick article, and then I move on back to more dev, right? These are like pretty high impact for the amount of time they take, which is nice, and the opposite of papers. Entropy stays above 1.0 for all runs. Is it all runs that it stays above 1.0 or just the good runs? That one's good. Oh, 0.8. Note that the entropy coefficient is included in the hyperparameter sweep, so low entropy zones are explored. The sweep was allowed to set as low as 1e minus 5, but there were no good runs in this range. All the best runs set entropy above 1e minus 3. Entropy of best runs without sticky actions, from 0.9 to 1.4. What's up, Linky? We found a crazy bug in like the biggest RLN library out there. Entropy coefficient from these runs range from 1 minus 3 to 1 minus 2. This is good. Entropy of best runs with sticky actions. So bad. And we can just stop using it, right? Bet has raided the stream. Welcome, Bet. We found a crazy thing. We found a real crazy thing. We're all in voice chat. Let me finish this paragraph. I will order my food, answer a couple questions if there are any here, and then I'll come by. An assassination tweet? What? What? What did you say? Wait. Did I miss like a major news thing? Oh, dude. Okay, you confused the heck out of me. No, I said that let me finish this article, let me finish writing this paragraph, let me order my food, and then I'll swing by the voice after maybe I answer a few questions. I don't know what the heck you thought you heard me say. You said that, and I thought I missed like a major US event. Derisive tweet? No, I'm just posting. I'm not going to post this article now. This is a bad time zone to post on. I'll post this in the morning. I should rename this discussion. Removing. I'm gonna make a cool point for some of the viewers here, since some folks are still around. So here's the point, and then I'm gonna write this up into a paragraph. You have to take into account that this is not just a one frame delay, right? You're training with frame skip, usually frame skip 3 to 5, usually 4 or 5. Mikado used frame skip 5. So you submit your action, right? It delays 5 frames, and then potentially your action gets repeated, and then it skips another 5 frames. So you're delayed a full 10 frames, right? Which is a sixth of a second, which is quite a substantial amount of time. But then there's another 1 in 5 chance that it skips again. So 15 frames, right? Which is now a quarter of a second, which is definitely enough time in like Pong for you to miss the ball, right? So that's 1 in 16 chance for that, and then a 1 in 64 chance that you miss 20 frames. And mind you, you're not just missing the frame, your key is being held down. So like your paddle's going past the ball or something. Yeah. Okay, this is wrong. I do like this. Let me do the full math on this. 17 seconds. Oh, I have to be a little careful with this, right? Okay, I'm going to explain this math in a second. Let me finish writing it out. The one additional thing I should do is I should try to actually play the stupid game with frame skip. I actually don't think that the wrapper will let you, though. I think if you do human mode, it won't let you. And then there was one other point. So let me go through this again. So if you just do out the basic math, I'd kind of done this in my head, but I didn't even realize it was this bad. Now I understand why you're losing like 4 or 5 points a game instead of just 1 based on this. If you do the math with Atari's frame rate, about every 85 seconds, your controls just lock up for a half of a second. So, you know, these games are pretty reactive. Like, the Atari games are actually pretty fast. They're actually pretty hard. Your controls locking up for a half a second, means the paddle's going to slide right by the ball, and you just lose a point. Simple as that. You know, the really sad thing about this is that this could have been prevented by somebody having, like, tried to play any of these games with sticky actions on. Can we even do that? We're going to definitely do that before I post this article. It's getting late, so I'm not going to do it right now. I'm going to finish writing it. What was the other objection? Why is regularizer not a word? Go away. Eh. Okay. Whole debacle could have been prevented by spending a couple hours trying to play Atari with sticky action. Rerunning sweeps. We'll just duplicate the sentence. Okay. Let me make sure these last couple paragraphs are good. I'll obviously read this one more time in the morning. Won't removing sticky actions make Atari too easy? Maybe, but this is a dumb source of difficulty. The math for this is very simple and obvious to anyone who's actually played Atari. Mikado et al. use a frame skip of 5. This means that the agent submits an action, 5 frames pass, and then control returns to the player. there is a 1 in 4 chance that their action gets repeated, delaying the return of control for another 5 frames. So 1 in 4 for a 10-frame delay, yada, yada, yada. Accounting for frame skip, you should expect a 30-frame delay every 1024 times 5 is 5120 frames, or every 85 seconds with Atari's 60 FPS. So every 85 seconds, if you're playing Pong, your controls freeze up for half a second and the paddle keeps sliding. Not exactly the best source of difficulty. I noticed Mikado et al. Do better on some environments. Not all games will be lost if you lose control for half a second. In these cases, it is in the span of... Not all games will be lost in the span of half a second. In these cases, it is possible that sticky actions act as a regularizer. There are probably better ways to achieve the same result, but if you really want to use sticky actions, treat it as a hyperparameter. Sweeps can then automatically discover the best value based on the environment. Hey JBL, we found something crazy. 1 second, and I'll tell you. Sweeps can then automatically discover the best value based on the environment. But definitely don't set it to 0.25 for all environments. In an earlier sweep, I didn't find a good setting for Pong above 0.13. Okay. Conclusions: one of the biggest advantages of using games as research environments is that they are easy to interpret. All you have to do is play them. This whole debacle could have been prevented by spending a couple hours trying to play Atari with sticky actions. I will be removing this setting from PufferLib defaults and rerunning Hyperparameter sweeps. You can support my work by following me and starting PufferLib. Perfect. Okay. It seems like most of the crowd has gotten bored of watching me write an article, which is very understandable. We got a couple stars out of this stream. I'm very happy with that. Did it end up being possible to song... Hey, Relu and JBL. Okay, welcome back. No, I was completely right. This thing is cursed, and this has destroyed Atari as a benchmark. It's that bad. Yes, I proved it. Yo, Will, it's that bad. So I ran a comprehensive hyperparameter sweep with their sticky actions. It caps out at about 16, which is exactly the number that they reported in their original results with DQN. I ran, 168 experiments. And then if I run it without sticky actions, it immediately finds hyperparameters that solve the environment at 20. It's that bad. So I did a whole bunch of additional analysis. I've got an article ready to go for tomorrow. But yeah, completely destroy the field with this one easy trick. I mean, can you imagine how stupid that is? Of course reinforcement looks dumb if... of course reinforcement learning looks stupid, right? If, we can't solve Pong. Well, it turns out we can't solve Pong because we have this stupid wrapper. Well, let me put it this way. I did some back of the envelope. Every 85 seconds, on average, that the agent plays Pong, the controls freeze up for a full half of a second and the paddle keeps sliding. If you've played Atari, it's kind of fast, right? Yeah, you totally lose. In that half a second that the paddle slides back, you're done. Yeah, this is earth-shattering, right? Crazy. So, sticky actions considered harmful. Publish this tomorrow. Dude, this field is so cursed and it's so avoidable. Think about it. If anybody bothered to play this for a couple hours, yeah, see you, Will. If anybody bothered to play this for half an hour, even, you'd really quickly see that you can't play the game with these sticky actions on, right? Well, we got this ready to go for tomorrow. Hopefully people see this one. Oh, let's go I'm going to go order myself dinner on the side here real quick. And then I'm going to find a cool title for this. I'll answer some chat questions if there are any. and I'll go because it's already 8 p.m. I actually usually go to bed by 9 because I get up early. Let me figure out what the heck I want to eat. Order something. It's too late for me to do anything else. Let me get some pasta real quick. Wait, so what happened? Let me explain in a second. Let me just order my dinner because otherwise, like, I'm going to forget to and I'm going to be hungry. Chicken parm. Just order myself, like, some chicken parm or something. Perfect. Just order this and then I'll tell you. Cool. Let's go through. I've been co-working on a different cool environment that I'll talk about. Well, we'll see when I talk about, but all day. So I haven't had time to do too much. Okay, so JBL, the thing that happened is I found in the default wrapper of Atari. So if you use ALE Pi, so what's... Yeah, so this is a 2,000 star repo, right? This is used in like every paper, like 90% of Atari, 90% of RL papers out there. The default setting in this includes sticky actions. By default, if you don't look at it, it has sticky actions. Here's a paper that introduced sticky actions. It has over 600 citations, massive paper for reinforcement learning. The paper says that sticky actions do not hurt performance in DQN. It is wrong. I can prove it's wrong based on only the data in this paper and the original DQN paper. You can see it's wrong. I ran 300 follow-up experiments, 300 trials, like 250 experiment hyperparameter sweeps on Pong with PPO as well. I replicate almost exactly their result, which is that they do not even learn how to play Pong with sticky actions. Immediately solve it within a couple of trials of hyperparam sweep without sticky actions. Show that the original motivation for doing this doesn't make any sense because these algorithms are not learning deterministic policies anyways. It was like this weird hypothetical construction, like an invented problem. This solves an invented problem and invents a real problem. That's what this does. This solves an invented problem and invents a real problem. So yeah, big day for RL. I mean, you got to think about it as well. Like, how stupid does reinforcement learning look when you can't even solve Pong, right? How stupid does reinforcement learning look when you can't even solve Pong? Well, it turns out you can solve Pong. You can solve Pong. How quickly do you think we can solve Pong? I haven't even checked. I'm confident. Let's do this live. We'll do it live. Filter above 15. We're going to consider 19 score to be solved, I'd say, right? 20 score? Okay, whatever. 20 score in 3 minutes. We solve Pong in 3 minutes. 1 GPU, not even using C++ vectorization, no fancy tricks. We solve it in 3 minutes. If we do it by samples, because people like sample efficiency for some reason, it's not even going to be that bad. Yeah, it's like 4 million samples or whatever, compared to like 2 million if you use a sample efficient algorithm that takes 2 hours. Now, this isn't DQN. This is PPO with an LSTM. This is just whatever I have in the puffer defaults. DQN does solve Pong, though. It's DQN with this stupid wrapper that doesn't solve Pong. Article will be live tomorrow. But, where is it? If you look at the original charts in the paper, basically, and then you look at the DQN charts, original DQN solves Pong perfectly. Their version with sticky actions does not solve Pong. They get a score of about 15. My PPO with an LSTM gets a score of about 15 if you use their stupid sticky actions thing. If you do the math, that checks out. Basically, sticky actions make you lose a quarter of your games. It's that simple. And it makes a ton of sense if you think through it as well. I do some like envelope math down here. Ain't that funny? It's stupid. Stop doing that. Stop inventing problems. Enough problems. ChatGPT's got to get me a title. Narrate a suitably epic cover art in a 3-to-1 ratio landscape for this article. Let's see if it does anything cool. How do you go about choosing the RL algorithm you use? For example, PPO and TD3 can be used interchangeably, but I usually just choose which I'm more familiar with without any proper reasoning. My reasoning is that PPO solves Dodo with a one-layer LSTM, so it's probably fine. PPO's been the default since 2017. Nothing has conclusively shown it's better. This is kind of funny. This is actually kind of funny artwork, isn't it? I kind of like that. I just said like, hey, I proved like a crazy thing. I found a crazy thing. Generate me some cool cover art. Yeah. I generally like. I don't even. Here's the thing. I don't even do. Oh shoot! I have to like. It's not going to be able to do the same image again. Here, ratio, same image. Let's see. Here's the thing though. If you're still there, like, I don't even focus on algorithm implementations in Puffer. I've been making so much progress in RL without even doing anything on the algorithm implementation side because it's like infra being cursed is the main thing. Infra's crazy cursed. More than anything. Which of these is the best? This one's pretty cool. The stupid aspect ratio is wrong, though. I don't know if it actually can do the aspect ratio I want. I really wish it had the ability to, like, edit existing images. Oh yeah, thanks. You made it less wide. Perfect. I don't know. We'll see. Maybe it crops differently. That's not bad. I like that. Cool. Well, this is ready to go for tomorrow. Y'all get a sneak peek for dropping by the stream tonight. I'll say this one more time because this stream keeps turning new people over. Um, this is all public work. Like the hyperparam sweeps for this, the optimizer algorithm, the like solving Pong in 3 minutes. This is all free and available in PufferLib. If you want to help my workout, I'm working on this full time. All you have to do is start the repo. That's all I ask. It helps me out a whole ton. This has been the growth on the project since I started working on it full time. This is the exact type of thing that PufferLib needs, like, in order for me to actually get all this out there and to fix all this stuff in RL. I'm not going anywhere, but the support sure helps. So thank you. Other than that, this article will be live tomorrow on X. My X is strictly for research. It's pretty much, that's all I do. I don't know, occasionally I get bored and post dumb replies to stuff, but the posts are just about research. I'll put it in chat one more time, because this is where the article will be tomorrow. And I will be streaming tomorrow MOBA Dev. We'll see maybe if I have time in the morning to, like, mess with these sweeps, but I do have a sneak preview, which is this run from from this morning. We have a 5 billion step MOBA run, which is rather interesting, right? So I ran this for 5 billion steps. It looks like it takes 99 towers, 99 problems, 99 towers. And yeah, it's pretty good. So we'll look at what this does tomorrow. I'm working on like miniature Dota as an RL environment at 1,000,000 FPS. So if that sounds interesting, drop by tomorrow. I'll be live a lot earlier. I've been streaming all my dev lately for fun. But otherwise, I will catch you later. I gotta go grab dinner. See you around.